All right, I'm going to go over some important things from discussion week 7. Test 3 has a lot of details in it, so I want to make sure I cover everything pretty thoroughly. All right, out of these 4 pictures, graph A, B, C, and D, to understand whether one is a function or not, you have to look at whether there are 2 y values for the same x. In other words, in this graph here, where x is, let's just go to 1, 2, 3, and y is 1, 2, maybe 2.5 or 2 3/4, where x is 3, you have a negative point. Where x is 2, you have a positive point. Where x is 2, you have a negative. And that's not okay. Where x is 2 and there's 1 point, that's a function, not another point along this vertical line. But here, where x is 0, there's 2 points on that vertical line. Where x is -1, there's 2 points on the vertical line. And a vertical line fails the vertical line test. Because where x in this picture is 1, 2, 3, 4, y has several values. It has value 1, 2, 3, 4, 5. So it is not a function. This one is not a function. This one is a function, and this one is a function. Just because it's curved doesn't mean it can't be a function. If you have this, as we saw, not a function, but if you have that same shape drawn this way, it is a function. Because for every x value, there's only one y value because the line keeps moving along. This is not vertical. It keeps moving this way across because it's going outward. Okay. Now, if it were to curve back on itself, if this line were to do that, then it would no longer be a function. So anytime you see lines curving back on themselves, it's not a function. It could even be a circle, and that's not a function. So a function, not a function, and not a function. On these equations, the reason I have problems in red are different from the first 3 is because the way they're written is different and you solve them differently. In this case, you have f of x, that's the function. So f of x equals 3x minus 1, or y equals 3x minus 1. Evaluate f where x is 5. So you replace the 5 with this x. And I'm going to work out this problem in a minute. A lot of people understood that really well. But here, when you see it written this way, that's the same so far. F of x equals 3x minus 1. However, in this situation, the x is not given. The entire function equals 5. So this whole piece, 3x minus 1, is set equal to 5. And then you solve for the x. So that's the difference. Where we're going to take our lovely 5 value and replace it. So 3 times 5, that's replacing the 5 for the x value, minus 1. And of course, order of operations says multiply and then subtract. So you have 14 as the answer. In this situation, they're not telling you x equals 5, but the f of x is 5. This part equals 5, so you put the 5 there, and then you have to solve for the x. So then, of course, that's our fun rearranging. We're going to add 1 to both sides, which will then give us 6 equal 3x. Because this goes away right here. Plus 1 minus 1 goes away. And then we're going to divide each side by 3 because 3 times x is multiplication. We do the opposite. To take the 3x apart, 3 over 3 is 1 because any number over itself equals 1. So that becomes 1x, which equals x. So this equals just plain ordinary x. And 6 divided by 3 is 2. So this you have now 2 equals x. That's the difference between those problems. So when you are working out these two, they're done like the first one. You take the 3 and it becomes the value for C. Just because there's more than one C doesn't matter. You could still just plug 3 into each of those spots. And negative 10 plugs into here. Down here, this is like this one here. G of x equals 1. So remember, they're telling us the whole thing, the whole function equals 1. So we replace the 1 here. That's 1. So 1 equals 1/2 x minus 3. Now how we deal with these fractions, this whole fraction is the coefficient of x. The whole thing is the coefficient of x. Just like a 2x, 2 is the coefficient of this x, meaning 2 times x. And this is 1/2 times x. But we don't want to mess with that term first. You have to really look and say the like terms. This is a term. This whole thing is a term. 1/2 x is a term. And 1 is a term. And like term says these two are alike. The -3 and the +1 are alike. So those two are combined. Now, since they're on the opposite sides of the equal sign, we have to treat it a little different. Just like the other problem, in order to get this thing over to the other side of the equal sign, we have to add 3 to both sides. So that 1 plus 3 becomes 4. This goes away, -3 plus 3, and then you're still left with this term, 1/2 x. Okay? Now we still divide, and I've gone through this on another video. We can still divide each side by 1/2. That's kind of really annoying because you've got 4 divided by 1/2, 1/2 divided by 1/2 times x. The good news about 1/2 divided by 1/2 is it cancels because it's still the same thing over the same thing. It's just a fraction over the fraction. This is where it gets sticky. You have 4 divided by 1/2. And there's a couple of ways to do it. I know students might do this differently. You go 4 over 1, always put a whole number over 1, multiply by the reciprocal, which will give you 8. So really now, 8 equals x. That's our answer. So a faster way to think of this, and I've shown this before, is you really multiply both sides of this equation by the reciprocal of 1/2. Okay, when you multiply by the reciprocal, you get 1 back. Because 1 times 2 is 2. 2 times 1 is 2. So you have a fraction of 2 over 2, which is 1. So you can always, when you have these fractions, you multiply by the reciprocal, 2 over 1. But whatever you do to one side, you have to do to the other side, 2 over 1. And you put the 4 over 1 because you're multiplying. So then you can get rid of. Let's put this x over 1 because that's also over 1. So that 2 cancels. All this, of course, the point was to get it all to go away except for the x. So that when you did this multiplication, 4 times 2, and you get 8 over 1, which is really just the number 8. So the answer is 8, as we saw before. Let's look at the rest of these problems. What I think is if you had any of these problems you didn't do correctly, go back and do them again. So let's look down here. All right, I gave you a hint with the color coding. In any case, the domain is all the values of x, all the x coordinates. Okay, so domain are all the x values of each of those coordinates. A coordinate is an x and a y value. And coordinates refer to a graph. Each one of these are coordinates, x, y, x, y. They're just calling it f of x. So you can see where this set of coordinates is -4, 6. This is x, and that's the f of x. Right there, the 6. The domain of f, all that means is a term that means the x values. So you simply list the x values. -4, -2, 0, 2, 4, 6. That's the domain of f, all the x values. The range of f, or the range of the function, or the range of the equation, is all the values of f of x. So you would list 6, 3, -2, 1, 5, 7. And I color-coded that. This could also be thought about as y. So when they ask for which set of consecutive x values, meaning for which set of all these values here in this top row, is f increasing? Meaning 6 to 3 goes down, so that doesn't work. Where x is -4 and -2, the f of x is decreasing. 3 to -2 is decreasing, so it's not there. It increases between -2 to 1, 1 to 5, 5 and 7. So the values of x, where f is increasing, are these values here, 0, 2, 4, 6. So you would say the x values where f increases are between 0 and 6. And that's what you would have to write down. Determine the maximum output. Remember y, or f of x, is output. The maximum output is 7. And the input where that occurs is 6. 6 is the input where 7 happens. So the coordinate with the maximum output is 6, 7. The x value and the f of x. Where the output is maximum of 7, the input was 6. That's what they're trying to say. So where the output is minimum, lowest, that's -2. And that happens when x equals 0. So the coordinate, the lowest output, where that happens is where x equals 0. Okay? And remember, these points, or these coordinates, mean a point on a line. That's another point on the line. And that's a point on the line. These points, when drawn together, make the line. Write f as a set of ordered pairs. The whole function is a set of ordered pairs. Those ordered pairs are -4, 6. -2, 3. And how do we write that whole set of ordered pairs? Okay, so 6, 7 being the last set of ordered pairs. These all are points. Every single one of them you can find is a point, and they all come from one line. So a function that is linear. So a linear function contains points on a line, and a linear function is also a linear equation. And you're learning about the linear equation. Now it says determine f -4. That means, again, they're telling you x is -4. Use the chart. Where f is -4, the function is 6. Where f of x is -2, that's this. The value of x is 0. Okay, you don't have to do any fancy math. You just look at the chart. That's why I have printed there, use the chart. Okay, I hope this overall explains